Hello, my name is Sakshi Manjunath. Today I'll be presenting my AET on advanced geothermal systems, tapping Earth's inner heat. We'll explore how geothermal energy works, what advanced systems are, the latest innovations, and also how they can help in the clean energy transitions. We'll also look at the advantages, challenges, and the future outlook. Geothermal energy comes from the heat that is stored inside the Earth's crust. Unlike solar and wind, it's not dependent on weather conditions, making it a very reliable, renewable energy source. Currently, it contributes about 60 gigawatts globally as of 2025. It's used for both generating electricity and for direct heating applications like homes, greenhouses, and spas. Advanced systems aim to make geothermal energy accessible even in the places without natural hot water reservoirs. In the above diagram, you can see the Earth in cross section. The outer surface is called crust, then comes asthenosphere, mantle, outer core, and inner core. This is the place where the temperature is maximum inside the Earth. Basic principle. Earth's heat comes from the two main sources, radioactive decay of minerals and leftover heat from the Earth's formation. So, if we see the working process, we drill wells into the geothermal zones where the hot water or the steam is present. The steam rises and spins the turbine, producing electricity. Then, water is re injected into the ground, making it a sustainable closed loop. So, the key benefit we see here is unlike solar or wind, geothermal plants provide 24 bar 7 base load energy. We can see it in the above diagram how the geothermal power plant works. What are advanced geothermal systems? AGS, also known as Enhanced Geothermal Systems or EGS, create artificial reservoirs in hot, dry rock using hydraulic fracturing. This allows us to produce geothermal energy even outside the volcanic areas, making it usable in many more regions. Some systems use closed loops where no fluid mixes with the underground reservoirs. This avoids issues like contamination or seismic activity. The main takeaway here is advanced systems aim to make geothermal energy universal. So in the above diagram, we can see how advanced or enhanced geothermal system is different from the conventional geothermal systems. Recent advances up to 2025. So first one is super hot rock geothermal. Instead of 200 to 300 degrees centigrade, wells are drilled into the rocks hotter than 400 degrees centigrade. Water becomes supercritical fuel, carrying much more energy, up to 10 times more electricity per well. Though still experimental, it could make plants much more efficient. It is very clearly shown in the first diagram where today's commercial hydrothermal systems, how it is different from super hot rock geothermal. Second one is closed loop geothermal. Uses sealed pipes or borehole exchangers, that is, no water injection. This avoids the fluid loss, contamination, and seismic risks. Germany's EVOR Loop project in 2024 is already testing this successfully. So, in the beside diagram, we can see the difference between the open loop and closed loop systems. Continuing with more advances, third one is next gen drilling. Traditional drilling is slow and costly. New methods like plasma drilling and millimeter wave technology melts the rock much faster. This reduces the time, cost, and making the deep geothermal feasible worldwide. You can clearly see it in the beside diagram how the next gen drilling looks. Then the fourth one is hybrid systems. Geothermal heat can also be combined with hydrogen production. Excess geothermal energy can power the electrolyzers to produce hydrogen, which becomes a clean fuel for storage and transport. This way, geothermal supports not just the electricity but also hydrogen economy. In the beside diagram, it is shown how the hybrid system works. Real world applications. Ireland heats 90% of the homes with geothermal energy. Kenya's Rift Valley generates more than 45% of the country's electricity. In Nevada, USA, a 5 megawatt advanced geothermal project started in 2023. Germany had its first commercial airward loop in 2024. Beyond electricity, geothermal is also used for heating, greenhouses, aquaculture, and even spas. Advancement and challenges of advanced geothermal systems. Clean and renewable. AGS is very clean and produces almost no CO2 emissions, which makes it environmental friendly. However, drilling deep into the earth and handling the fluids must be done carefully to avoid the negative impacts. Base load power. Unlike solar and wind, which depend on the weather, geothermal provide 24 bar 7 continuous electricity. The challenge is that setting up these plants is still very costly, so adaptation is a bit slow. Then vast potential. The existing part is that AGS can unlock geothermal energy almost anywhere on the earth, not just the volcanic regions. But the downside is that exploration and the drilling require advanced technology and are very expensive. Economic stability. Once built, geothermal plants provide long-term, stable and cheap power. But the challenge is that the initial setup costs are very high, which can be a barrier for many countries. Then grid resilience. Geothermal adds strength to the energy grid by diversifying the energy mix and keeping supply stable. However, one concern is that creating the artificial reservoirs can something trigger the seismic activity, which needs careful monitoring. If we see future scalability, with continuous innovation, AGS has the potential to expand worldwide, but its success will depend on the public awareness, government support, and the policy that encourage the investment. So next is future outlook and conclusion. Global expansion. By 2030, EGS could make geothermal available across 70% of land areas. High efficiency. Super hot rock projects may generate up to 10 times more power. Energy transition role. Geothermal is a reliable baseload energy that reduces the fossil fuel dependence. Then integration with future tech. It can integrate with smart grids, hydrogen production, and storage, making it more scalable. Cornerstone of clean energy. So by 2050, geothermal could supply hundreds of gigawatts worldwide, becoming the cornerstone of clean energy transition in the universe. The last slide references or citations. The information here comes from the trusted sources like USDOE, which is about Geothermal Technologies Office reports, then International Energy Agency, Renewable Energy Outlook 2025, then for raw energy and year-old project case studies, academic journals on EGS systems, then the visuals or the diagram which is used here is from the open source websites. Thank you.